Well, what else is there to say about Algebra 2? It's always a good time. Our topic today is called the sum and difference of two angles. So before I dive in and show you all the formulas, I want to just talk about why we need this. So our first example is the sine of 90 the same thing or equivalent to the sine of 30 plus the sine of 60? And here's what some people like to do. They like to say, well, 30 plus 60 is 90, so the sine of 30 plus the sine of 60 must be equal to the sine of 90. And let's go through and see if that's true or not. The sine of 90, so recall that's on our graph. Okay, my sine curve starts at 0, 1, 0, negative 1, 0. So if I go to pi over 2, which of course is 90, we can see that the sine of 90 is 1. Is that equal to the sine of 30 plus the sine of 60? Well, the sine of 30 is the first term in our chart, which is 1/2. Sine of 60 is radical 3 over 2. Clearly, does that look like it's equal to 1? 1 plus radical 3 over 2? I would definitely say, no, these are not equal. You can't just split 90 in half and say it's 30 plus 60. So what we have are all these different formulas that we're going to see in a moment. And we're going to use those to find the sum and difference of two angles. So you're definitely going to have to hit the pause button, copy these down nice and carefully. This again is given on the exam. You do not have to memorize. Let me say that again. Don't memorize these. They're given to you. There's enough to memorize in this course. And let me just talk about each one real quickly. Clearly, this one is for sine. These two are for sine. These two are for cosine. These two are for tangent. Sum means you're adding. So you'll notice on this first example, it says the sine and then it's a plus b. So that's for the sum. A minus b would be for the difference. Then the cosine has a sum, cosine has a difference, tangent has a sum, tangent has a difference. Very simple. We're just going to follow the formula. So question 1. If sine x equals 12/3 and cosine y equals 3/5, x and y are acute angles, find the value of the cosine of x minus y. Looks like such a simple question, but there's actually a lot of work involved behind it. So first, we're going to have to draw pictures. So let's get that in our notebook. You have to draw a sketch. Okay, you can't do this without one. Now, they're going to be very specific on where to draw these. And you'll notice it says x and y are acute angles. So if you're acute, think back to your geometry days, that means you're less than 90 degrees. So if I go and put my quadrants, less than 90 would be in quadrant number 1. And both of them are in there. So I'm going to draw two separate pictures. So the first thing I like to do is I'm going to call this triangle, this is for x. This is all about x. So x is an acute angle, so I know it's in triangle 1. It's got to look like the bow tie. So it makes a perpendicular to the x-axis. Theta, or x in this case, is at the origin. And I know sine. Remember, that's SOHCAHTOA. SOHCAHTOA. So is opposite over hypotenuse. My opposite, it says, is 12. My hypotenuse is 13. Where am I getting that from? It says the sine of x equals 12 over 13. Opposite hypotenuse. Find the missing side. Quick Pythagorean Theorem. I'm hoping you got this one memorized. I'm going to go with 5. And I know it's a positive 5 because I'm moving to the right. I'm going to do the same thing now for my y. Okay, y is also a positive acute angle. So I know I'm in quadrant 1, 2. Perpendicular to the x-axis, I'm going to put a y in this theta spot, because it's y. And this time, they tell me the cosine of y is 3/5. So I think back to SOHCAHTOA, ka is a over h. So my adjacent side is 3, hypotenuse is 15. There's another Pythagorean triple if you've got it memorized. It's a 3, 4, 5. Again, it's going up, so it's a positive 4. Now, you pretty much have the hard work done just drawing the two triangles. Now you're going to evaluate the question. So the question itself was to find the cosine of x minus y. So here's what we do. You have to just recognize that it's a difference formula and that the formula is given to you. That's the other hard part, is just knowing that that formula is on the sheet. So I look at my sum and difference, and again I know it's difference because it says minus. I find the one that starts with cosine, so that's these two. And I pick the one that says cosine of something minus something. And I'm just going to copy that down. Now I am going to change the variables because notice I don't have a and b in my question, I have x and y. So I'm going to replace my a's with x's and my b's with y's. And I'm just going to recopy this formula down. So I'm going to say it's the cosine of x minus y equals the cosine of x, cosine of y. Notice it has a plus sign in it. Sine of x, sine of y. Okay? And now, this is actually fairly simple. I'm just going to look at my pictures to evaluate these. It says cosine of x. So I'm going to go to the triangle that I called x, which is this one. And I'm going to say, okay, cosine, so katoa, is adjacent over hypotenuse. So based off x, here's my adjacent, here's my hypotenuse. So in place of cos x, I'm putting 5 over 13. Now it wants the cosine of y. So now I go to my y triangle, which is this guy. And I take the cosine of y, which again is adjacent over hypotenuse. So 3 over 5. Then you keep your plus sign. Now it says sine of x, so I'm going back to the x triangle, and I'm going to take the sine value. Sine is opposite over hypotenuse, so that's 12 over 13. And now it says sine of y, so I go back to the y triangle, and I take the sine of y. Opposite over hypotenuse looks like 4/5. Alright, at this point, I just have to clean this puppy up, and we're going to stress doing this without a calculator. For a little practice here, when you multiply fractions, you just multiply the tops and bottoms. So I'm going to start with 5 times 3 is 15. 13 times 5 is 65. On the top here, 12 times 4 is 48. 13 times 5 is 65. I have a common denominator, so I'm just going to add the numerators. 48 plus 15 is 63 over 65. And you've got your answer. And that's all there is to it. So you just got to draw those pictures out, pick the right formula, substitute them in, and you're good to go. Let's try another. All right, example 2. Give an angle A in quadrant 2 with sine A equals 12 over 13th, and angle B is in quadrant 3 with cosine B equals -3/5. Find the sine of x plus y. So again, before I even attempt to try this problem, I've got to draw 2 pictures based off where these are sitting. Okay, and again, make them separate pictures here. So I'm going to start with angle A, and they come out and just straight up and tell me it's in quadrant 2. So my bow tie has to sit in quadrant 2. I'm going to use A at my theta spot and perpendicular to the x-axis there. And now I'm going to label what they gave me. They said the sine of A is 12 over 13. So katoa, so that's O over opposite. Opposite's 12, hypotenuse is 13. Again, Pythagorean Theorem, or if you have that one memorized, that's your 5, 12, 13. But here's the catch. You're starting at the origin and you're moving to the left. What type of number are you if you move to the left from the origin? Hopefully you're saying a -5. And that's the catch in these problems. My second one, so I like to just highlight, I know it's on there, I'm just going to make it clear that this is for triangle A. Triangle B. It says it's in quadrant 3, so again, you don't have to guess, they came out and told you. Make it a bow tie perpendicular to the x-axis. The cosine of this one is -3/5. So again, SOHCAHTOA, that's my adjacent over hypotenuse. -3/5. Does it make sense that I put a negative on this side? I hope so. I move from the origin to the left. Again, this is a triple, 3, 4, 5. Hopefully you have that memorized, or Pythagorean Theorem. And again, you've got to catch. You're going from the x-axis down. What type of number should that be? Make sure you slap a -4 on there. All right, lastly, you did the hard part. The easy part's just picking the formula. It says the sine of x plus y. So I go to the formulas they give me. I look for sine, so I don't need any of these guys. And I want the one that says x plus y. And, I guess that's a typo on my fault. I really should have said the sine of a plus b since my angles are a and b. So I'm going to rewrite that for you. I really want the sine of a plus b because I did use angle A and angle b. And that's his first choice. So all you're going to do is copy that formula down. Sine of a plus b. Sine A, cos b, plus cos A, sine b. And then you just go to each picture and take what you want. So it says A, so I'm looking in this triangle. What is the sine of A? Opposite over hypotenuse, so I should have 12/13. Cosine of B, go to your B triangle. Okay, cosine is adjacent over hypotenuse. Notice they gave you that one, so -3/5. and there was a plus sign. Go back to your A triangle and take the cosine, so adjacent over hypotenuse, so negative 5/13. And then the sine of B, go back to your B triangle. Sine would be opposite over hypotenuse, negative 4/5. Okay, so that SOHCAHTOA is not going away, guys. We got to make sure you had those memorized from, your 9th grade math, and we reviewed it in the beginning here. So again, we're going to go non-calculator. Just going to multiply across the top, across the bottom. 12 times negative 3 makes negative 36. 13 times 5, of course, is 65. Negative 4 times negative 5 makes a positive 20 over 65. When we add fractions, we simply keep the denominator and add the numerators. So that looks like negative 16 over 65. And there you go. All right, let's try one with tangent. Tan A equals 2/3, tan B equals 3. Express the tangent of A minus B as a fraction in simplest form. Now, you'll notice these are significantly uglier than the first two. All these fractions are goofy. But like normal, we're just going to draw our two triangles. I've got one for triangle A, one for triangle B. Now, they don't tell me what quadrant I'm in. And in fact, I didn't actually need the pictures for this one. Look at the formulas. This says the tangent of A, which is given, plus the tangent of B, which is given. And then it's 1 minus the tangent of A, which is given, and the tangent of B. So I'm actually given everything in these formulas. So in this case, I'm not even going to finish drawing these out. I'm just going to go straight to the formula. It says the tangent of A minus B, so I'm going to find that one, which is here, and copy that down. So the tangent of A minus B equals tan A minus tan B, I'm squeezing it in there, sorry, over 1 plus tan A, tan B. All right, let me get some more room here. All right, so I'm just going to plug and chug here. It's the tangent of A, which they told me is right here. Tangent of A is 2/3, minus the tangent of B, which they tell me is 3. And since there are fractions already, I'm going to make it a 3/1, all over 1 plus the tangent of A times the tangent of B. So that's 1 plus 2/3 times 3/1. So all you got to do is watch your order of operations and you should be in good shape. So I'm going to multiply, of course, first. So I'm just cleaning up. I've got 2/3 minus 3/1 all over 1 plus 2 times 3 is going to be 6/3. Now 6 divided by 3, of course, is 2. So I actually have 2/3 minus 3/1 all over 1 plus 2, which is 3. Now again, I like to treat this as a complex fraction, so I'm going to actually make this bottom one into a fraction by putting it over 1. And I'm going to say to myself, okay, in complex fractions, all I have to do is find the common denominator and multiply every term by it. Well, if you have 3's and 1's, clearly that's 3. I'm going to multiply every term by the number 3. Now the whole point of that is that things should cancel. 3 on top, 3 on the bottom leaves me with 2. And there's the minus sign. 3 and 1 don't cancel, but 3 times 3 is 9. All over, again, 3 times 3 is 9. And it looks like I've got negative 7/9. And there you go. I've got a few more different types, so stick with me here. All right, next question. Express the sign of 90 minus theta. The expression 90 minus theta is equivalent to what? Okay, so again, the smartest thing you have to do is recognize that this is a difference of two angles. And that's what's got to jump in your head. And then you'll know to look at the sheet. And how do you know that? Again, you just see a minus sign between two angles. So there's no pictures to draw, there's no fractions given. All I have to do is say, okay, where's the sign of the difference of two angles? And it's that second one there. And I'm going to copy that down. So it says the sign of A minus B equals sine A cos B minus cos A sine B. And now, because my problem, you'll notice, like doesn't have A's and B's, I'll put it in terms of my problem. So I'm going to treat this, whatever came first, as my A, whatever came second, as my B. So I'm going to replace all my A's with 90, and I'm going to replace all my B's with theta. So I'm going to say this is the sine of 90 minus theta. That's what the question was asking for. So again, all my a's turn into 90s, b's turn into theta. So I'm going to get the sine of 90, cosine of theta, minus the cosine of 90, sine of theta. So you just had to turn it into the variables or numbers in your problem. Now, again, you're just going to evaluate, of course, without a calculator. 90 comes from your sine chart. Okay, pi over 2 pi, 3 pi over 2, 2 pi. 90, our sine starts at 0 to 1, 0, negative 1, 0. So the sine of 90, remember it's 90, 180, 270, 360. The sine of 90 is 1. Cosine of theta minus, now what's the cosine of 90? So draw out the cosine curve. Cosine starts at 1, 0, negative 1, 0, 1. Cosine of 90 is 0. Now what's 0 times anything? You've got it. 0. That kills that side. So basically this turns into 1 times cosine theta, or just cosine theta. So one little hint is, if you have a number and a variable in the problem, like I did here, a 90 and a theta, you're going to end up with a theta in your answer. Alright, you've got the next one on your own here. Notice I don't have any triangles to draw. I've got a value and an x, so I know there's going to be an x in my answer. Figure out which one you're going to go with, pause it, try it on your own, see if we get the same thing. So again, pause it, try it on your own. Alright, let's see if we pick the same formula. I saw cosine of pi minus x, so I went with the difference of cosine. And again, that minus doesn't mean anything's negative, it's telling me difference instead of sum. And then I said, okay, my pi is like a, my x is like b, so I replaced all my a's with pi's and all my b's with x's. Now it's just time to evaluate this. So pi is not one I have memorized, it's just from my sine and cosine curve. So I've got pi over 2 pi, 3 pi over 2, 2 pi. Cosine starts at 1, 0, negative 1, 0, 1. So the cosine of pi should be negative 1 times the cosine of x, plus, we'll do the same thing for sine. Oops. Pi over 2 pi, 3 pi over 2, 2 pi. Sine starts at 0, max at 1, 0, min 0. So the sine of pi is 0, and 0 times anything here is 0. So it looks like I get an answer of negative cosine x. Okay, I've got 2 more examples here that kind of work backwards. So if you're ever given something like this first example, you just have to recognize, again, that it came from one of these goofy formulas. So notice what it says. Cosine 30 cosine 22 minus sine 30 minus sine 22. So all I do is I kind of look back at this and I say, okay, that looks like one of these formulas. Which one starts cos cos minus sine sine? And I'm kind of going, okay, cos cos minus sine sine. That's this guy right here. So this is the formula they're talking about. And what is that formula when you see cos cos minus sine sine? Well, it's actually the cosine of the angle A plus the angle B. So I would say this is the cosine of, what is your angle A? 30 plus 22. I would say this is equivalent to the cosine of 52. Easy enough? So you're just matching it up and kind of working backwards. Let's try the next example. You're looking for sine cos plus cosine. Sine cos plus cosine. So go back here. Sine cos plus cosine. Looks like it's one of these two. Sine cos plus cosine. So that's telling me it's the sine of the A value plus the B value. So it's the sine of 25 plus 30. I would say that is the sine of 55. Easy enough. Okay, we're winding down with some of the hardest questions we've been stumped on our exam for the past few years. This came as a shock to a lot of people. They said on a previous exam to find the sine of 210 degrees. And almost everybody froze because that's not one you have memorized. You have to know your 30, 60, 45, and we had those down the first week we started trig. And then we added some new values. We had to know 0, 90, 180, 270, and 360. And again, those come from our sine graph. But nobody ever said you had to know the sine of 210. And I know I can't just type it in the calculator because it's its exact value. So here's what you had to do. You actually had to use the sum or difference. And you had to say to yourself, could you come up with two angles that either add or subtract to 210 where you know them? So could you use these two numbers, any of these two numbers in this box here, and pick two of them to add up to 210? Well, I definitely think so. Have you got them yet? I definitely think you could use 180 plus 30. Would you agree that's the same thing as the sine of 210, 180 plus 30? Now, the only way to actually answer that question now is to use one of your sum or difference angles. So I'm clearly going to go to the sine section, and I'm going to go to the sum, so I can cross those off. And the sine of 180 plus 30 is going to be, so again I'm using this as my A and this is my B. I'm going to say that's equivalent to the sine of 180, my A value, times the cosine of B, so the cosine of 30, plus the cosine of A, which is 180, and the sine of B, which is 30. And now I can evaluate this without a calculator. Let me take the two easy ones. The cosine of 30 is radical 3 over 2. Sine of 30 is 1/2. Now these two come from your graph, remember. The sine of 180 equals 0, 1, 0. There's my pi or 180. Cosine graph starts at 1, 0, negative 1. So times negative 1, and you should know those values by now. 0 times that is gone, and it looks like my answer is just negative 1/2. I promise, let me just give you one more. All right, find the exact value of the cosine of 150. Now remember, you want to break that down, exact value, no calculator, into two numbers you know. So you've got 30, 60, 45, 0, 90, 180, 270. Clearly it's bigger. I'm not going to use anybody bigger than 150. So I'm either using 30, 60, 45, 0, 90. Can any of those together come together and make 150? Well, certainly. 60 plus 90. And it doesn't matter the order you do them in. All right, so now I'll pick my formula. Clearly I want cosine, I want a sum. I'm going to go with this guy. And again, I'm just going to say this is my A and this is my B. So I've got the cosine of 60 and then the cosine of 90 plus the sine of 60 and the sine of 90. All right, again, just plug and chug, no calculator. The cosine of 60 is 1/2. The sine of 60 is radical 3 over 2. Those should be your two easy ones. Now picture the graphs. Cosine graph at 90, it's my first tick mark, is 0, which is beautiful. It kills that whole side. Sine of 90. Sine starts at 0. At 90, it's at 1. So my final answer, radical 3 over 2. Well, have a great night, and we'll see you tomorrow.